Next shift register is the serial in parallel out, or the SIPO shift register. This is ideal for converting a serial input in data into a parallel data string that can be transmitted that way. The reset is optional, as the reset function will just clear all the outputs for the D-type latches irrespective of the clock pulses. If you do not want to use the reset, you can just overwrite the previous data with a new set of bits that come in. So the operation, we want to, let's say, move, or our first input at the data in over here is a 1. When we receive the clock pulse, falling edge or lagging edge, when we receive that clock pulse, that 1 is going to move into the position of Q0. Going to move into position of Q0. When we then insert our second input, a 0, and we introduce a clock pulse, on the lagging edge, the clock will trigger flip-flop 1, so that 1 is going to move to Q1's output, and that 0 is going to move into Q0's position. The next pulse, before we do that, we need to activate the next input, which is, let's say, a 1. So that next 1 is now put in there. When we receive the clock pulse, that 1 will move to the output Q2. That 0 will move into position at Q1. That 1 will move into Q0's position. When we give the next input, let's say a 0 again, and we introduce the clock pulse, that 1 will move to the output Q3. That 0 will move into output Q2. That 1 will move into output Q1, and that 0 will move into output Q0. So we can see with each consecutive clock pulse, all the bits will move one position onwards. Once all my outputs are loaded, we can then use a counter or a ripple counter to then activate the receiving end of the parallel, so that the information can then be transmitted to the receiver, or we can then trigger the enable of a adder, which will then add those binary numbers. And there we've got the operation of the serial in, parallel out.